All right. So as you rightly said that uh, data is nothing but information, right? And when we talk about information, it can be anything, right? It has no limit today about any information that what can be the data and what cannot be the data, right? We talk about when we are on the servers, we have logs, right? Every time you do something, some information is getting stored there. So those are called log files. We write emails, we send emails, we receive emails. So even that is a data because we write some text on that which we need to communicate. The message, what I know, I wanted to send it to somebody else, or I may want to inquire some information about, right? So even email is a data. We have social media, we keep posting, a lot of things on the social media nowadays. You talk about Facebook, Twitter, you talk about Instagram, right? So many things we have it available, and we are posting pictures, we are posting text, we are forwarding the message, we are liking it, we are commenting it, we use emojis over there, right? And there is no limit, there is no type or limitation at any point of time today that the what kind of information we are sharing, we are receiving, and we are consuming, right? So the data can be anything. It can be text, it can be an image, it can be a video, it can be an audio, it can be live streaming what we are talking about, right? So that's about data, right? And when we go on the business front, when people who are working in sales, they will have sales data that, okay, this many items I have sold, this many items I have purchased, this is my profit, this is my loss, right? Kind of things. If you go to hospital, you will be asked first to fill up a form, your name, email ID, phone number, and so on, your personal information, what problem you have got, since when you have, do you have any other allergies or something like that, and you will be providing all of that information. That patient file goes to the doctor. Doctor reviews that, and based on that, he will ask or she will ask you hundreds of questions about your problem, and then they will prescribe you some medicine, right? So all of that is in the form of data. You can have sports data, you can have somewhere nowadays everywhere. If you see on the roads, traffic cameras are installed by the traffic police of Bangalore, right? So wherever you go, you will see that the in data is coming from several forms, in several formats, from several methods and areas, right? And we don't know what to do with that data, right? So if we are talking about the security cameras, maybe traffic police is using those video feeds to identify that if someone is breaking the traffic rules, because for them literally it is not possible to put every signal a traffic police, right? So they need to have some kind of mechanism that will help them to collect the data, right? And then they will analyze the data, and based on that, if somebody has broken the traffic rule, you will have a ticket sent to your house address or wherever it is, right? Whatever is your registered address in the RTO. So why so much, what we have so much of data, right? What do we do about this data is what, when we start understanding this data, we can make a lot of meaning about it, right? So it can help organizations, right? When we talk about larger organization, it can help their own environment, their, if they have some kind of issues, right? And if they have some kind of business opportunities, like for example, if we look at Reliance Jio, right? If we talk about 5 7 years before, every company was running about tariff rates. You call and somebody will charge 30 paisa, somebody will charge 40 paisa, somebody would say I would give you 4 minutes in a in 1 rupees, right? But when Reliance came into the market, they did the analysis of the data that where is people are paying money, right? They looked at that people are paying money behind the calls. There nobody is bothered about data. So what Geo decided, okay, now what I would do is I would say that call is free. So kill the competition, right? Call is free. Geo is the first company which started call is free. You don't have to pay for call anymore. I will charge you only for data. right? You take consume 1 GB, 2 GB, 10 GB, 20 GB. I'll charge you only for that data. So that one simple decision, right? One simple information helped a company build $1 billion today, right? So data has so much of power that if you understand the data, right? If you know how to collect the data, if you understand the data, and then if you can bring some kind of meaning from the data, there is some hidden facts and figures available. If you can bring that meaning out of it, then you can have so much of opportunities available, which you can, exploit it to get a business decision, right? And that's the very reason all of the companies, right, are running behind the data. Okay. Any doubts so far?
No, sir, no.
Okay. So in,
Yeah, continue.
yeah, what exactly is data science then, right? It's it's a study of large quantities of data, right? When we say large quantity, what what can you call today as a large quantity? Is 100 KB is large quantity? Is 100 MB is large quantity? Is 100 GB is large quantity? Is it 100 TB is large quantity? Is it 100 petabyte is large quantity, right? What is that is the large quantity you can call it, right? It depends and it will change from context to context, right? When we're talking about the video data, maybe 100 GB is not a large quantity, maybe 100 petabyte is a large quantity. But when we are talking about text file, right, when the information is on the pure text, we may say that, okay, yeah, this probably 100 MB is a large quantity of text because 100 MB of text, maybe billions of pages of text information, right? So that we can call that as a bigger quantity. So there is no hard and fast rule where you can say that, yeah, this is the large quantity of data for this thing, right? It would change from context to context, but that data can be utilized to understand the organization challenges. It can be utilized to understand and find the business opportunities and make future decisions, right? So, so when we talk about data, it's a study. It's a kind of mechanism which we do on the information available with us, and then we make decisions based on that, right? And there are so many parts of data science careers here available, which will require you to know about mathematics, science, and you need to have lot of curiosity. Okay, it is not plain and simple what you would have studied in your engineering. If you just think that I have data and you're getting bored with the data, maybe this is not the right field for you. But if you have a lot of curiosity, right? Like for example, if we look at a story of Newton, right? The he said that why apple falls from tree below, it doesn't go up, right? People at that point of time would have thought that okay, he's a fool, right? But was he a fool? No. He found some kind of theory today that world relies upon, right? So you may need to be a childist, you may need to be, very argumentative to talk about, to ask questions, to think about, to bring some different opinion than what people are talking about, right? And if you have that kind of behavior, and if you know mathematics, you know a little bit of science, you can utilize and you can combine all of together to do or to apply data, to bring some kind of decisions. And ultimately, when you do all of that, that will formulate for you, that you may be able to call yourself a data scientist. Right? This term was basically coined somewhere in 80s or 90s when some of the professors were trying to revamp or improvise the statistics, right? So earlier it was known as statistics. Today that is known as data science because they said that okay, it's obviously a math, it's obviously data on which we are working upon, right? But we apply science to bring some solution to that, and that's why they called as it's a data science. Okay, and basically those professor names were like DJ Patil or Andrew Gelman, who brought this term to the world, data science. But earlier it was known as statistics. This is one of the sexiest job of the 20th century, right? People call this as very hyped in the market. You might be hearing a lot in the market that this company is hiring this many data scientists, this many data scientists, but they have the requirement, but they don't have people to do that, right? Because it's very complex in nature to do the job of a data scientist. Okay, and you get paid very heavily. Believe me, a fresher can start the salary from 8 to 9 lakh rupees, which today in administration areas or maybe in development areas, if you would go, probably it would take for them to reach maybe 4 or 5 years of experience. But a good data scientist, even if you are a fresher, you can get salary up to 8 to 10 lakh rupees, depending on that, how good study you have done and how strong analytical ability you have. Okay. Any questions so far?
No, sir.
Okay. Are you able to understand what I'm trying to explain you?
Yeah, sir, I can understand.
Good. Anything which is bouncing?
No, 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 sir. No, no. Thing
Okay.
like that.
Great. So now we know about data, we know about data science, right? So what does it take for you to become a data scientist, right? So you need to know about science, which means you should know about physics, chemistry, biology. Okay. Why do you need to know this, right? Depending on the domain where you get employed with, right? Like for example, you get a job in a healthcare company. So there you will have data only about healthcare, that somebody has issue with dermatology, somebody has issue with ENT, somebody has cancer, somebody has skin diseases, somebody has abdomen related diseases, right? So you should be knowing about anything and everything about the biology so that you can understand that information which is given to you and you can apply mathematics on that to find the meaning from that data, right? So you require mathematics and you require science both to understand the data, right? And then you have the data, so the data somewhere it should be stored, right? So the data you can store it in various databases. You can have MS SQL, MySQL, MariaDB, and the list goes on, right? You have Cosmos, you have Postgre, you have big data, you have NoSQL, you have MongoDB, and this is limitless areas where the number of database applications are existing today. You can put them into, like either you know the basic SQL wherein you are just inserting and retrieving the data, or you also know the programming level of SQL, which is called PLSQL, wherein you can do literally change the way the database works, right? So you need to know science, you need to know database wherein you will store the data, right? And then you need cloud. Why do you need cloud? Because today the data size is so big that nobody can store on one server or maybe on your local laptop or a desktop. It's literally impossible because the data size is very huge and it's keep on growing every day, every minute. Look at the very same example which I talked about, traffic police, right? The the security cameras which is there on every signal. Imagine how many cameras are deployed across the Bangalore and how much data of recording it is generating every minute. You can understand the quantity of the data video recording which is happening every minute. It will be in zettabytes and petabytes, right? Literally it is not possible to store on one platform, one place. So you require a cloud which is a cluster of servers, a cluster of storage, right, where the data is continuously getting dumped, and as per the need, storage is automatically getting allocated. If 100 GB is full, another 100 GB is allocated. If another 100 is full, another 200 GB is allocated, depending on the speed of the data it is getting generated. Now that is just one area of it. Apart from that, since your data is growing, you also need a heavier computing power, right? For example, CPU, RAM. If the data is in the form of image and graphics, let's say you're using Facebook, right? We share so much of audios and videos, and many times we use pictures, right? We share it with our friends, family circles. So assume amount of data which is getting uploaded on Facebook, right? It's huge, it's enormous. You cannot even imagine how much data it is being generated, and it's literally not possible to push it on one place. So when we are talking about those kind of data, that will require GPU as well, right? So all of that is available on cloud. So you need to know cloud as well. And again, there are hundreds of clouds available, right? You have AWS, you have Azure, you have Oracle, you have SAP Cloud, you have Alibaba Cloud, right? And it's again limitless. So you need to know at least one of the platform, you need to know at least one of the database, right? And then you have a platform, you know where to store the data, right? Now you need to know how will you operate the data, or how will you apply mathematics and science on that data to get some meaning of that, right? For that, you require programming. You have C++, you have Java, you have C Sharp, you can use Perl, you can use Ruby, you can use Python, you can use MATLAB, you can use Julia, and list goes on. There is no limit to it, right? You have R as well, very famous nowadays. So any of the programming language you need to know. You need to know one cloud. You need to have at least one database knowledge. And this is by default requirement, irrespective which domain you're working. Let's say you're working in retail shop, let's say Walmart, right? Walmart is a retail company which has thousands of retail stores. Like in India, we have Reliance Fresh, Big Bazaar, right? They are very large multi-store or retail chains available across the cities, across the country, and some similarly there are so many, right? So if you're focused on a healthcare domain, your knowledge should focus on the science area, which is mathematics and the biology. If you're focused on something like, let's say, you're working in a chemical lab or chemical laboratory or a petroleum company, then you should focus on chemistry and mathematics. And if you're somewhere on the evolution or research and development kind of thing, you should focus on the physics and mathematics area, right? So you may not require everything at every place. Mathematics is common depending on the kind of problem you're solving. Science would change depending on the domain or the area of or the industry you are working upon, right? And then once you know the programming, you will know how to apply all of this. But apart from this, this is not sufficient for you to, become data scientist. You also need to know about designing the data models. You need to know how to write algorithms. You might have studied about data structures while studying C or C++ in your engineering, right? So you also need to know how to design different data models, right? And different data models will require for you to use different libraries, right? Some of them I have mentioned like SciPy, NumPy, Pandas, and the list goes on. There is no limit. And last but not the least, you also need to know about analytics and visualization, which means you should have analytical ability in yourself that nobody can teach you, right? But you have visualization tools available, like for example, you can use Excel, you can use programming libraries from Python such as Matplotlib or Seaborn or so on, right? You can use these things to provide visualization, like you can create a bar chart, you can use do pie chart, you can do scatter plot, you can do line chart and so on, right? So if you need to become a good data scientist, you should know how to tell the stories, and stories you can only tell if you know the visualization and analytics part of it. That means you may spend months and years together just to study one data model, but then when you're doing that presentation or of your analysis, you should be telling like a story, right? You should not be making people bored about it. So that's what it takes to become a data scientist. So ultimately, what exactly data scientist is, right? So data scientist is a person who will find solution to the problem by analyzing any big or a small data using appropriate tools. And the tools I have discussed in the prior slide. You should be able to tell the stories that what did you find about, right? You may need to talk to your boss, you may need to talk to somebody, department head, and so on. You need to tell them that, boss, what did I find from that? Right? For example, in your college, you have 100 students there. Somebody scored 99.5, somebody scored 99.9, somebody scored just 39, right? But you may have the data in terms of thousands of students in the university. You need to have a mechanism, you need to have tools to analyze that information and tell that, hey, this person did so much, he studied day, night, did projects, this, that, and that's how he or she was able to get 99.9. Just telling that 99.9 is the topper is not sufficient. You need to make the people understand, like it's a story, that okay, this lady, she studied days and nights together. I saw her, she was jumping here and there, she didn't have lights, she burned the stove, but she studied, right? So you're telling a story. Ultimately you have to tell just one data point that she is the topper, but you cannot tell that just directly. You need to make a way that they talk about it, they know about it, and they do things the way it is supposed to be. Okay, so in a nutshell, as long as you have curiosity, you have fluency in analytics, and you have an ability to tell the story by, tell the story, you tell your findings using a story, you can be considered as a data scientist. That's all it will take for you to become data scientist. Any questions so far?
No, sir.
Okay, that's a little bit of fact for you to read it. Okay, there is nothing to explain here, right? That and this is not the entire history of data science. This is how it began, right? Somewhere where we started using data science. So I'd let you read, and if you have any question, you let me know. All right. Uh, shall we move on?
Yes, sir.
Okay. Now this is how we would uh, begin the actual process, right? When we talk about data management, right? So we first need to know how to collect the data, right? Like if we look at the previous example again, the traffic police, they have security cameras installed on every signal. So they are use, using cameras as a live data collection model. So whenever you have a system in place, like the Bangalore traffic police, then that is called primary data collection, which will generally be not be possible for you while learning. You require a huge investment and infrastructure to have the primary data collection. Then you have secondary data collection, somewhere that data is in form, stored already. Either it is in the form of table, database, or in an Excel, right? Or maybe somewhere in a text file. So you have the data, you know how to collect it in your format the way you want it. So you may need to define some kind of model that how do you want to collect the data so that you can start working on it, right? Then comes data exploration. Data exploration is something that you will start understanding, you will start asking questions from here that, okay, what this data is all about. Maybe you have been just given the numbers for all of the universities of the entire country, right? We have hundreds of university, and you may be asked, okay, can you tell me which university is doing excellent in which science of engineering or which field of engineering, right? Sounds like a very simple question, but is it simple to answer? If you have hundreds of universities and then you have thousands of colleges inside those universities, right? And then you may have autonomous universities, autonomous colleges, right? So there will be billions of rows and the columns which you will be thrown upon, and you need to understand, study, and bring some meaning from that. And the answer you need to find is which university is doing best in which field of engineering, right? It's a pretty simple question. But is it simple to get that answer? No. You need to apply so much of brain to understand the data, right? So when you're doing that process, that's called data exploration, right? Now, in order to do the data exploration, you also need to know that how would you extract that data from there, right? So you may need to build some concepts. You may need to either you can do on a concept basis, which will be based on either science or mathematics or combination of both, or you may have your own logic. You may have your own logic to build that data model. Okay, we'll talk about these things when we go into the advanced study. I'm just trying to run you through to the basics of understanding that what data science is about. Okay, and then once you have done the data modeling, you will be in a position to start asking questions from that model of the data which you built, right? For example, let's say you have uh, what we can call it. Let's say you have a help desk, right? Help desk may have a technical support, may have a non-technical support. Let's take a simple example of your mobile phone. Which mobile operator you're using? Is it Vodafone, Jio, or Airtel? Deepak,
Yeah, sir. Yeah.
which company you're using?
Jio, sir.
Jio. So now Jio will have two kind of support, right? If you get a problem in your phone, you will call the Jio customer care, right? And Jio would
Yeah.
ask what problem you're facing. So the person who is receiving your call is not a technical person. He will just receive your questions and he'll create a ticket for you. The ticket will be sent to the person who is a technical team who will understand and solve your problem, right? So the model by which Jio has defined its customer support is that the customer calls to uh, the customer care, which will be a non-technical person, right? And then customer that so if I say like this, right? So probably understand this way, right? Uh, so you are the end customer, right? You will call it to the customer care, and then customer care will send it to the technical support. Now tech support will have their different divisions, different support, right? Somebody might be supporting network, somebody might be supporting database, somebody might be supporting, like uh, application, somebody might be supporting database, and so on, right? So how does this flow works? You are the customer. Where's the pencil here? Okay, so so you as a customer will call to this person, customer care. Customer care will understand your problem. They create a ticket and then they will send it to tech support. Now this tech support may be a direct team which is here sitting here, or it may be just a team of coordinators who knows which issue to send where. Okay, and this team who is sitting here will know if it is a network issue, then they will send it to network team. If it is a application issue, then they'll send it to application team. If it is a database issue, they'll send it to database team. And if it is like a product related issue, they'll send it to product team, right? There might be so many teams sitting in between, but you as a customer will not know that. Now these teams will work on your issues and then again they will send the response back to this person here, and then again From here it goes to this, and from here you get back your answer, right? So if I talk about this whole process, this itself is a data model, right? So this is the conceptual based model, right? That I have a concept which I have brought it into the reality that this is how it is happening. Now there can be logical models, right? The logical models can be that you have your own logic, right? And you want to bring it to the reality. That means it is just a theory, right? That does not exist anywhere. It is just a theory. And you want to bring it to the reality. Then if you are defining such kind of model, then that becomes your logical model. Any doubt? Deepak?
No, no, sir. No, sir. Continue, sir.
Okay.
Hmm.
Now, so that completes the theory part of it, right? And we begin working on the data science uh, by starting from the programming area, okay? And we will talk about Python first because when we look at the whole data science, right, it it requires multiple things for you to learn in terms of technology. You need to know database, you need to know cloud, you need to know programming, and you need to know designing the data models and the analytical tools. What is expected from you to have as a prerequisite, as a knowledge from yourself, is that you should have knowledge of science by yourself, so that wherever it is needed, you you can apply by yourself, or wherever the related concepts are explained, you can understand by yourself. If not, you can go and brush up those skills. If at places require certain things to be taught in mathematics, for example on statistics, it might be covered during part of your course. Okay. uh, and then we will talk about any one database, right? Whichever you choose to. We preferably use MySQL because that is free. Otherwise, you need to purchase the license for my MS SQL, Oracle, DB2, Mongo, and etc. Okay, nothing is free except MySQL. So we will use MySQL to train you about in terms of data storage if it is needed, or otherwise we can use the Excel based data sets which will be available on Kaggle. Okay. Uh, then
Okay, sir.
there is another requirement which you need to learn about, which is cloud. So you can learn either Azure, it will be completely your choice which cloud you want to pick up, or you can use IBM Cloud, or you can use AWS, okay, whichever choice you want to keep it. All these, they provide you initially some free, credit, using which you can begin your learning. Obviously, that will not be sufficient. Apart from this, there is another free service from Google, right, which is called, uh, 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 the, sorry, I just forgot the name. There is so much going on, right? So there is Google also provide Collaboratory. Okay, the name is Collaboratory, and there you have Jupyter and all, which you can use to write your program. So you may not need to know about all of that, right? And these all things will be taught to you as part of programming. Okay. Uh, so this will cover your study of data science. It will require almost 3 months of time. Okay, it might, which might extend probably to 4 months as well, but keep it a rough time of 3 months, uh, and 3 to 4 hours of daily study for you, which we will talk about during course. Okay.
Okay.
Uh, so we'll stop this session here today. Okay.
Okay.